Before we begin, if you enjoy realistic space documentaries and future human missions, subscribe to Dr. Malcolm. Every video here is a journey into the real future of space exploration. Now, for more than 50 years, humans have not walked on the moon. The last astronaut left in 1972. And when we finally go back, NASA is not returning to where we went before, not the familiar gray plains, not the Apollo landing sites. Instead, Artemis III is targeting one of the strangest and most dangerous places in the entire solar system, a place where the sun never rises, where temperatures are colder than Pluto, and where, hidden in eternal darkness, may lie the resource that makes a permanent human presence in space possible. NASA is going to the moon's south pole, and this decision might quietly become one of the most important moments in human history. Every Apollo mission landed near the moon's equator. There was a simple reason: it was the safest place. Flat terrain, predictable lighting, constant communication with Earth. Astronauts could see clearly, navigate easily, and their spacecraft could land with minimal risk. But Apollo was never meant to stay. It was a visit, a demonstration, plant the flag, collect samples, come home. Artemis is different. Artemis is not about visiting the moon, it is about living there. And the equator, surprisingly, is actually a terrible place to build a long-term human base. Because the moon has a problem, a massive one: night. On Earth, night lasts hours. On the moon, night lasts 14 days. For 2 full weeks, the sun disappears. Temperatures plunge to around minus 170 degrees Celsius. Solar panels stop working, batteries freeze, electronics fail. Even modern technology struggles to survive a single lunar night. A permanent base at the equator would need nuclear power, or astronauts would have to evacuate every month. That makes a long-term presence extremely difficult. So NASA asked a different question. Instead of fighting the moon, what if we found a place where the sun never really sets? And they found one, at the very bottom of the moon. The moon's south pole is nothing like the moon you imagine. The moon doesn't tilt much on its axis, only about 1.5 degrees. Because of that, sunlight hits the poles at a very shallow angle. This creates towering crater rims and mountain peaks that remain illuminated almost all the time. Scientists call them peaks of eternal light. Some locations receive sunlight for over 80–90% of the year. For a lunar base, this is priceless. It means near constant solar power, stable temperatures, and continuous operations. But that's not the real reason NASA chose it. The real reason lies just meters away in darkness. Right beside those sunlit ridges are deep craters, and sunlight has never reached them. Not for thousands, not for millions, possibly not for billions of years. These are called permanently shadowed regions. Inside them, temperatures fall below minus 230 degrees Celsius, colder than Pluto, colder than Neptune's moons. And when scientists pointed radar instruments and orbital spectrometers into these craters, they discovered something shocking: water, frozen water, ice. Water on the moon is not just drinking water, it is survival. Because water can be split into hydrogen, rocket fuel, oxygen, breathable air. This means a lunar base could produce air for astronauts, drinking water, and fuel for spacecraft. This changes space travel completely. Launching fuel from Earth is incredibly expensive. Every kilogram requires a rocket. But if fuel can be produced on the moon, spacecraft could launch from the moon's weaker gravity and travel to Mars or beyond. The moon stops being a destination, it becomes a spaceport. Artemis III is not just a landing mission, it is a scouting mission for humanity's first off-world fuel station. But the South Pole is also the most dangerous place humans have ever attempted to land. The terrain is chaotic, sharp craters, steep slopes, boulders everywhere, and the lighting is tricky. Because the sun sits low on the horizon, shadows stretch for kilometers. Depth perception becomes extremely difficult. An astronaut could be standing beside a crater hundreds of meters deep and barely see it. Landing here requires precision beyond Apollo. This is why NASA's human landing system built by SpaceX is so important. Starship won't land like Apollo's small lander. It will be a towering spacecraft descending carefully into one of the narrow safe zones near the crater rim. This will be the most complex moon landing ever attempted. If Artemis III succeeds, something historic quietly happens. For For the first time, humans won't just visit another world. We will choose a place where we intend to stay. The South Pole offers power, resources, fuel, and a stepping stone to Mars. Future astronauts may live there for months, then years. And one day, spacecraft leaving the moon, fueled by lunar ice, may carry the first humans to another planet. In a way, the road to Mars does not begin on Earth. It begins in a frozen crater at the bottom of the moon. The Apollo missions proved we could reach the moon. Artemis is trying to prove we can live beyond Earth. And it all starts at the South Pole. If you enjoyed this journey into real future space missions, subscribe to Dr. Malcolm and join me as we follow humanity's next giant leap, step by step. I'll see you in the next mission.